guest, Chad Campbell, and we're really excited that he's here. Thank you for being here, and thank all of you for being here. Do we have any new members tonight? Is anybody a new member? No, maybe. Well, if you are new, we give you a special welcome. And I want to give a special shout out to our new annual sponsor, ZFG Architects, also Invisible Structures. We have three other annual sponsors, Atomic Irrigation, Louis Polson, and Shimahara Visual. So we're very grateful to those organizations for supporting us. And with that, I will hand it over to Sarah.
Hi guys. I just want to say a couple of quick things. First is a little bit of housekeeping. Firstly, we'd like to record this so that we can watch it later, take notes, but come back to it and learn again. So if you want to be anonymous, just turn your video off and that should work great. Secondly, we would like to have everyone put their questions in the chat and remain on mute. It'll make it easier for us to all hear Chad. And then I'm going to just take a minute to talk a little bit about why we're doing this and why it's important to know about Title 24 energy calculations. So I know I can't see everybody, and I just told everybody to turn their videos off if they're not interested, but maybe a show of hands. I mean, how many people here are, or raise your hand using the reaction button, how many people here have read through a Title 24 energy report before? I mean, no, yeah, okay, there's a thumbs up. Yeah, there's a couple. It's not a problem if you haven't. There's a couple, there's another. Okay, okay, good. Okay, good. Yeah, we just wanted to kind of gauge, you know, where everybody's at. It's a good thing to know, and I'm glad that a lot of you are here if you haven't read through one before. So quickly, my name is Sarah Garina. I'm a licensed architect, and I've been working in residential construction for 20 years. And I'm currently working with Landry Design Group, and Chad is somebody who we use all the time. He's our favorite Title 24 energy consultant. And so, and when we talk about him, even in our committee, everybody got really excited because I think a lot of people know Chad throughout like the city, and Newton Energy is kind of common. So it's pretty exciting that, you know, we all, if you don't know of him, maybe you should. So anyway, I'm just going to take a minute to talk just in general about Title 24 energy calcs. It's part of Title 24 energy is part of the building code set of volumes that we need to follow in order to get a building permitted. And so energy is a segment of the building code. So every 3 years, the energy code gets updated, and every 3 years, it's more and more challenging. And I feel like I kind of relearn it every 3 years. So it's a good thing to just get started being fluent in, or at least being able to understand a little bit. And we'll talk about what you need to know. But it's also just really good to start learning the vocabulary and enough so that you can start just asking questions. The point of it is to, at least in homes, is to the state is trying to reduce our use of energy. You know, the energy code is trying to get us to have our buildings use less energy. And any building that's new or remodeled, certain levels of remodel are required to comply with this. So it's really important for everyone, especially in residential architecture, which is what I work in. I'm sure it's complicated in other building types. So for professionals working and building and getting permitted buildings, the challenge is compliance. So we need to have our Title 24 energy calcs attached to our drawings in order to get a permit. And that means that we have to comply to get a permit. And our company, it's the challenges of it are the amount and type of insulation that's required. And the other challenge is the amount and type of glazing. Sort of those two things are our major issues. Other things aren't as challenging for us, but those seem to be like our big, the things that we work through with people like Chad. So we've been using Chad because they're creative, and they respond to our questions well. Like I can call him and Chad here and ask him a whole bunch of questions, and they're really dumb questions a lot of the time, but it's just helping me get a handle on what he does and how essentially to get our drawings and our building permitted. That's my main goal a lot of the time, and to try to keep our design intent, keep our skylights if we can, keep the amount of glass that we have. So that's the challenge, and I feel like what it would be good for all of us to come out of this with is a sense of how to read, what you're looking for when you read a report. What are the kind of things that you're looking for to help you understand what the energy engineer has assumed on your project? And then you can start a dialogue about what it is that you would like to have instead. So anyway, those are some goals for us as a group, but that's my goal in general when I'm thinking about Title 24 energy as an architect on my side of the table. So with that, I'll hand this over to Chad. You can take it from here.
All right, thank you very much. So my name is Chad Campbell. I've been an energy consultant now for 27 years. Started when energy compliance was a single sheet of paper that you added up your points, and if your points were positive, you complied. Now the reports have become 40, 50 pages in some cases because of all the different requirements that we are trying to achieve, explain, because there's so many parties involved. You have the architect, you have the owner, you have the builder, you have the planning department, building inspectors, HERS raters, many different people are all having to read the report and get information from it. So this will be a general overview with Title 24, and then I'm always open for questions. So with that, I'm going to go ahead and get started, and then we'll see where we end up. Come on. All right, let's see. So first of all, energy compliance came about because of the WARREN-ALQUIST Act that was passed in 1974 that created the California Energy Commission, which was due in part due to the energy crisis that hit during the 70s. And Al Alquist and Carl Warren were two California legislators that said, we need to start preserving energy in the state of California, even back in 74, before it was coal. They did this, and with it, the WARREN-ALQUIST Act allows them, as stated, basically to prescribe the regulation for lighting, insulation, climate control systems, or your HVAC, and other building designs and construction standards. The WARREN-ALQUIST Act requires the energy code to be revised and reviewed every 3 to 4 years. It was every 5 to 7 prior to 2001, when we had the huge rolling blackouts that really hammered California, when they deregulated the power companies and they all went, okay, we all going to charge $300 a kilowatt instead of 30. So there was a huge push to move it to every 3 years, and that's where we've been ever since. And with that, usually it's an incremental increase in difficulty from 5 to 10 to 12%, depending on what new innovations had shown up in the marketplace. So, and then, come on. There we go. So with Title 24, there's 2 different approaches in order to achieve compliance. The first is prescriptive approach. And the prescriptive approach is the easiest way, it's the simplest way to comply, but there's no flexibility in it. It's equivalent to a recipe. You have to use A, B, and C, or you do not comply. And the problem with the prescriptive is you may not be able to get where you need to be because of the restrictions. You're only limited to 20 square feet, 20% window to floor area. Only 5% of that can face west. The performance values for the windows are very restrictive, and most of the time we only use this in the rare 1 or 2% out of all the projects we've ever worked on. And being that I'm coming up on about 11,000 projects. It's not very many. The other approach that we have is the performance approach. And with the performance approach, you are allowed trade-offs between the features of a building. You can trade out more efficient heating and cooling systems to allow less expensive windows and doors, or add more skylight to your project. The ability performance, hands down is where the creativity side comes from. You're allowed, and plus you can also do cost analysis. You can go, we want to add 100 square feet of skylight to our project. What would it cost? And we can tell you, well, in order for that to work, you would need this level of glass that's $100 more a square foot than it was for the previous class. And then you can juggle the value to see if it's worthwhile to go that route. Kind of jump into just a few things that, we look at to, try and save money and, keep your projects under cost, would be the cool roof, which would be a roofing material that has been rated by the Cool Roof Rating Council. And each product has a age solar reflectance and a thermal emittance. And within those products, they start out very simple and they get very, 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 very cost savings as far as your energy usage. The whiter the material, the more reflectance and thermal emittance you get. And this does have a huge impact on houses, especially in hotter climates, Palm Springs, Los Angeles area, not so much the South Bay or Malibu or Santa Barbara, but more inland areas really benefited from the cool roof products. And the green code on certain cities actually is requiring cool roof products, whether you want them or not. So most times when you re-roof a house, after you've done an addition or an alteration, they'll necessitate a minimum cool roof rating for those products. And then underneath that cool roof, for your attic areas, we have these products called radiant barrier sheathings, which is roof sheeting plywood that has a foil-backed radiant barrier applied to the product that keeps the heat in during the winter and keeps the heat out during the summer, and helps your attic areas maintain a much more comfortable area for heating and cooling purposes. And then as you can see, it's the cost, this is on a side note, the cost of the sheets is $20.75. Not a normal 8-foot sheet of plywood is maybe $19. So you're maybe $1 more a square foot, but the energy savings I have seen have been anywhere from 8 to 12% improvement on your energy budgets just by having the radiant barrier. And okay, I'm going to click out of this for a second. Forgive me. These were in order. All right, big topic, glazing. Glazing, as you know, represents 80% of your loss for heating, cooling, lighting. Everything happens with the windows and doors. The better the window or the lower the U factor of the glass, the better the product is. So U factor is the representation of how much heat will pass through a given material over a certain amount of time. So the lower the number, obviously, the less amount. The other component to glazing is called solar heat gain coefficient, and it measures the percentage of radiant heat that passes through the product into the house. The lower the SHGC, the darker the glass, the tinting. But there are products out there that have a low SHGC, but still have a high visible light transmittance, which is the other caveat to this. The visible light transmittance helps, allows you to see inside your house. And then the last bit that, goes with the windows is air leakage, but with most modern day windows, air leakage is almost non-existent. The housing today, are much more airtight. You're not losing your conditioned air through the windows. Now you're losing it through vent pipes, through exhaust fans, or the errant left open door. But the windows themselves do not leak as they used to. So we've seen huge improvements in that regards. And then when you are looking at windows and doors, this is the values that we will be using in our report. It's the NFRC label, which stands for the National Fenestration Rating Council. And it will, on these stickers, you'll have your U factor posted, your solar heat gain, your visible transmittant, and your air leakage. These are the stickers that the inspectors will take the energy report and will be comparing the energy report to these to make sure they match. If they don't match, then you either need to rework the Title 24 or replace the window. And usually it's easier to rework the Title 24 in most cases. Some cases, though, you do have homeowners that make decisions outside of your control, and they go with companies that say they have NFRC ratings and they end up not having any ratings at all. And thus we're stuck using default values for those products, which are horribly worse than any NFRC rated product you will have on site. Some examples of the different types and where the gas would be going. So, and you have single pane, dual pane, triple pane windows are starting to become an option for people due to the more stringent requirements of Title 24 and trying to make up for the large amount of glass that's showing up on some projects. I have some projects I've worked on that, I kid you not, were 140% window to floor area. So for example, 1,000 square foot house has 1,400 square feet of glass in it. And the program, just is not happy with that. And most times when you're looking at, a glass makeup, you have your framing material, you have your outer pane, which is where the low E coating is attached. Then you have your gas in the middle, and most times it's just air, but you will see argon or krypton. Unfortunately, those gases really only last 2 years, maybe. And then, because unfortunately the molecules of argon and krypton are very tiny, and no matter how airtight you make something, they still eventually leak out. And then you have your second pane of glass, which is where you might have a second tint, or it might just be clear. But most window constructions is very similar to this shown here. But one of the things that we do look for, since metal windows are still very, very popular, especially because of their sight lines and the way they look, they have a problem though in that metal conducts heat faster than any other product, less air. So you have to find a way to break that bridge. And by doing that, you do the thermal break, where you have these green little tabs that connect the two halves of metal together to hold the window in place. The only bad part is that a thermally broken sliding door, because it pivots back and forth, has the ability to become a flexi flyer and twist and lock up and not work. So when talking about windows and doors with energy consultants, be wary when they start mentioning thermal break. There's a lot of great product, but just know that if it's an operable window or a door, there could be issues down the road for twisting, and causing issues. And then here's an example of how the low E coating would work on a typical window. This is a low E coating. So the low E coating would be on the inside pane of the outer pane of glass where the orange is hitting. So the heat is being reflected because of the low E coating. The UV light itself is being reflected. Only a small portion of UV light is allowed to pass through. So, you know, your carpets won't fade, paintings won't turn different colors. There's a lot that happens with solar, UV when it comes through. Visible light is still allowed to pass through until it gets to the second pane. And if it's clear, then it will continue and there will be no problem. If there's a second layer, a tint or another coating, then this is where your SHGC would get much, much lower. And then because of the low E and the airspace in between the glass, heat from the winter stays in the house because you have this insulative barrier between the two panes of glass. And then skylights. Skylights are an awesome thing. They have their purpose. They bring light and ventilation to areas of the house that don't have access to a window or to a door. The only bad part is that skylights are, according to the California Energy Commission, are one of the worst things that you can do to a roof, in that you're punching a hole in a perfectly good insulated roof product. For example, a typical R30 attic roof has a U factor of 0.034. The best skylight that's made today, that's triple pane with argon and laminate and everything else, has a U factor of 0.330. So you're talking 300 times worse in that regard. So when we're doing our reports, skylights, they will decimate your energy budget quickly, and you'll have to come up with other ways to get around it. They should be taken, they are needed. Again, you have powder rooms, you have laundry rooms, but they do hit us hard. On the equivalent of 1 square foot of skylight is equivalent to roughly 10 square feet of window on any orientation, any surface. So just keep that in mind. I mean, don't get rid of skylights. I mean, by all means, skylights are awesome. Just be temperate with them. Don't just put them everywhere, because we'll be asking you as an energy consultant, okay, can we get rid of this one and get rid of this one and maybe that one? You can keep these just to try and get your place into budget. That's the easiest way to make a building comply, is by reducing the amount of skylights. And then when you're in your design phase, there are some options to consider, just as, these are ideas that we would offer to you in ways to get it to comply. The first one is properly sized overhangs, eaves and balconies. An overhang, every climate zone goes a long way, but there is such a thing as too much overhang. The 2019 energy code that we are working under is pushing towards a passive heating model. They would like houses to heat themselves via the sun. But at the same time, you don't want to cook the house because you don't have any overhang. So, you possibly, extending an overhang or shrinking an overhang may be possible options in order to get you into compliance. Another option would be adding continuous rigid insulation to the exterior of the house or on top of the roof, as seen in the picture here on the right. Here's a picture of a house that is fully wrapped in rigid board, and the rigid board isn't that much more. I mean, there is cost to it, but the uninterrupted insulation that wraps this building is almost better than doing closed cell spray foam within the cavity of the wall itself. And closed cell spray foam, on a side note, is 3 to 4 times as expensive as regular batt insulation. So it's one of those things that you definitely can trade off. And the other thing is, you will have builders that will push back against this and say, this is not how we do it. This is not how things are done. And my only answer is, all the buildings here in Arizona where it's hot are wrapped in exterior insulation. They don't balk at it. They literally have pallets of rigid board show up and they just start attaching it, and then they stucco over the top or do siding, whatever the exterior is going to be, but they have no problem attaching it. So just another thing to kind of think about. Not that we do this very often, but it is some ways to make your building more energy compliant. A few other things: high performance ventilated attics, where you have insulation at the ceiling joists for your designs, but then you add a second layer up at the rafters. So you end up trapping the air between two insulated barriers, and the air itself becomes a third insulation for the roof, giving you a huge amount of return on your investment. This works great. Climate Zone 9, LA, Beverly Hills, Inland Empire, we see this a lot. The other thing that you will start seeing more and more is the requirement for unventilated attics, due to the high fire nature that Malibu experienced and Paradise, and there's going to be more, unfortunately, given the way that things are going. So unventilated attics do benefit us for Title 24, but there's certain insulation requirements that you need to meet in order to qualify for those. And then here is the typical example of a regular attic insulation. You can see it's just here at the ceiling joists. And then over on the right side, you can see where the insulation has been placed up in the rafters as well, getting us better credit for performance. And just as a side note, high performance attics are mandatory under the prescriptive approach. You don't have a choice. So again, it's the cookbook recipe where you have to do it, A, B, and C. I'm sorry, if you don't comply. And then let's move on to HVAC, heating and cooling. The items that use the most energy in your house are your heating and cooling systems. But you're trying to maintain 70 degrees, in your house most times throughout the year. So in the winter, you're running your furnace or your heat pump. In the summer, you're running your AC, which is all I ever run out here. Basically, the units, there's a few different ways that you can have mechanical systems. You can have gas furnaces that are split. So you would have in the middle here, you have a gas furnace with a split AC unit that would be on the side of the house. And those are very, very efficient. You can get them up to 98%. And on the cooling side for the AC units, they can get up to 20 SEER, no problem. And huge amount of savings can be had by that. The picture just below that would be a packaged unit where both the heating and the AC is wrapped into one. You'll see this a lot where people don't have space on the ground in order to set an AC unit, and they don't really have an attic in order to place a furnace. They'll set a package unit on the roof and then duct down into the house. The other two options that are becoming quite common are the heat pump units. The one up above is a ductless mini split system that has a condensing unit that you would place outside, and then you have a fan coil unit that the cooled or heated air will be blown out of with no ducts, and gives you maximum flexibility in how to heat and cool your house, as you only have to heat whatever room you're in. You know, with the gas furnace, the split system, as well as the package system, most times you're heating and cooling the entire house all at the same time, whether you're in the back bedroom or you're in the kitchen, or, you know, that whole, you're trying to heat and cool the whole house. With the mini split system, or in the below VRF style system, you can control each room individually, and your electricity usage, energy use in general, will be much lower. And the efficiencies are getting better and better all the time. And then, so basically the way the heat pump system works is during the heating season, the heat pumps move heat from the cool outdoors into the warm house. And then during cooling season, heat pumps pull the heat out from the house and bring cool in. It's kind of a reverse heat exchanger in that it does all of the work without needing any gas. You have just the one unit, and it does all quite well. Excuse me. Heat pumps are, you know, you have a couple different options for heat pumps. You have air to air, which is your most common type system. You'll see it in 90% of the projects. You have water source heat pumps that will use like a pool of your house to cool the water, the lines down in order to bring cool air into the house. Or you could run the lines in the driveway underneath an asphalt driveway to get your heat during the winter. And the third one for heat pumps is the geothermal, and that actually taps into the warm nature that is Earth. There's a couple different ways that you can do it. Most people will drill boreholes that are 8 to 10 inches in diameter, 200 to 300 feet into the ground, and run piping into those with a glycol or a water-based system that exchanges the heat from the house into the ground, so that you're constantly getting 70-degree air all the time. There's, you know, it's very expensive, you know, especially depending, you know, where you're digging it, but you're always going to have hot and cold. Like you're never going to be like, oh, there's no gas today, or, oh, there's, you know, there's no excuses with the geothermal. It's just very expensive, and it takes the right person to set it up. The last one here is the high velocity system by Unico. It's the only company that makes it. They overpressurize their duct systems, and they have smaller ducts. So they have the ability to get in areas that most people do not. For average ductwork in a house is 8 to 12 inches. That goes into a register, whereas the Unico system, the lines are 4 inches, 6 inches in diameter. So much smaller areas, you know, the flexibility is awesome. The downside is they're noisy, because think of the volume of air moving through a 12-inch duct is, I mean, you've all heard your system turn on. Now imagine that same volume of air squeezed down to half the diameter, but the same amount of air is coming out. So just the sheer volume of air makes them extremely noisy. But if you're limited on space or on flexibility on how you're going to get ductwork to the different areas, this is a potential option. And then the last system is probably one of my favorites, is the combined hydronic systems. And the hydronic uses the same hot water that you use for cooking, cleaning, washing clothes to heat your house. And it's extremely efficient. There's a lot to be said for, and with it in Title 24, there is the ability to do cooling as well in Like you would do cooling lines in the ceiling, heating lines in the floor, and then the thermostats in the room would maintain the temperature wherever you want it to be. For a radiant heating system, you would have a boiler, which would flash heat all the water for you. And then you would have a storage tank on which to draw from for both for your domestic hot water as well as your heating and cooling. And it's because the boilers are as efficient as they guarantee a great return on the energy budget. If you look to the right, you actually see the latest setup that they're starting to do now is the tankless water heaters. So you can now program tankless water heating systems to provide the same radiant heating that you were expecting from a very large boiler, now condensed to something you can hang on the wall, in the garage, in a closet. And, and the efficiencies, again, because it's a tankless unit, the efficiencies are through the roof as far as what you can do with them. And then the last thing that I want to talk to in regards to design options, give me 1 second, okay, is HERS verifications. HERS verification is Home Energy Efficiency Resource Services. And these are tests that are done by a third party that some are mandatory, which we'll get to into a second, and some really help get your buildings to comply when other ways they would not. The first one that we'll start with is duct sealing, and duct sealing became mandatory in the 2013 energy code cycle, which went into effect July 1st, 2014. And with that, your ducts had to be leak tested, and so that they did not leak more than 10% of their volume over a 15-minute span. This doesn't affect you so much as a designer or an architect. It's more for the builder, but it's one of those things that it does pop up in your report, and just kind of one of those to be aware of, that this needs to be taken care of. The next one is IAQ, indoor air quality. Since houses are now being made to be tighter and tighter so that you're not wasting your conditioned air outside, interior air quality is a check by the HERS raters to make sure that you have enough fresh air either being brought in or being extracted from the house, which would cause more air to be brought in via what little leaks are left. The easiest way to meet your IAQ is with a bathroom exhaust fan. And it's simple that you just explain to them, yes, we're using the bathroom fan, and you put a sticker by the switch saying to be in operation while house is occupied. And that will more than qualify for your IAQ. There's many ways to meet the IAQ. You can do it with an exhaust fan. You can do it with a supply fan that would turn a damper on when your HVAC turns on to run normally, and it would bring in fresh air through your ductwork and distribute it through the house. The third way is to do it an exhaust and a supply fan, so that you are constantly maintaining balance within the house. You're not squeezing air out, you're not squeezing air in, you're constantly moving the air and changing it out. The third one, hot water pipe insulation, is a minor one, but when you're trying to get that last square foot of skylight in that the homeowner wants, it may be the ticket. And that would require all hot water lines within the house to be wrapped with 1 inch of foam insulation in order to maintain the heat in the line so that it gets to its location. Low leakage air handler unit verified is making sure that the furnace or the heat pump that's being used is on the AHRI's list of leakage handlers. It's a easier unit to use. It's an easier credit to use, but one that we don't check very often, as then we're not sure what units are going to be installed until they're installed. So it makes, it makes for confusion that we try to avoid. And then the ducts and condition, kind of self-explanatory. The ducts are all within the insulated volume of the house, not in the attic, not in the crawl space, not in the garage. It's all within the space. And most times you end up having to have a chase that it runs in, or a soffit, or some kind of drop ceiling in order to get that one. And then refrigerant charge verification is a simple test that they verify that your AC unit has enough refrigerant put into it so that it operates correctly. Nothing that you have to worry about, but it's one of those things that will pop up. And a lot of cities are now wanting to see this list of requirements on their cover sheets, so that when they're plan checking it, they go, oh, okay, so we're doing duct sealing, we're doing IAQ, we're doing ducts and condition, and we're doing refrigerant charge verification. And it seems to help in that you don't get inspectors going, hey, where's all this stuff? And they're like, oh, I didn't know I had to do that. And it's like, well, it was in the report. So, by putting it on the cover sheet of the plans, you can't miss it. Well, it still can be missed. But it's one of those that it makes it less easy to miss. And then a couple more that we'll go through. The biggest one that I want to talk about is quality insulation installation, QII. This one is, let's see today. Okay, QII is looking, and again, this is for the builders. This is not something that you as a designer has any control over, but it's something that you need to make the builder, the owners aware that it's going to be needed, is that all the insulation is installed correctly. Okay. Can you still hear me?
Yeah, we can hear you. We can't see you, but we can see the presentation though as well. Oh, now you're back.
It's weird. It just all of a sudden shut off. So the insulation. So the insulation needs to touch all 6 sides of the cavity that it's in: front, back, top, bottom, left, right. If it's not touching it, then your HERS rater will make the insulation contractor install it correctly. There's a lot of insulation guys that feel they need to charge more for the QII, but if they had been doing it correctly from the beginning, there wouldn't be a credit for QII. It's a quality assurance check for the homeowner, for you as the designer, that the building is being insulated correctly, and that you're not going to have that call at, hey, it's 2:30 in the morning and I can't get my house to stay warm no matter what I do. And it's because of stuff where, insulation doesn't go all the way to the top plate, or there's gaps in the roof. So, and the other thing is that with Title 24, QII is not mandatory in that you have to do it. It's being required though, because the standard house that your house is being compared to is taking credit for the QII. So if you do not select the QII, you start at a disadvantage within your energy budget compared to the standard house you're being modeled against. And that basically, and QII it's more or less you're creating a air barrier around the building as well as an insulated barrier. Those 2 things will, save you energy usage, your heating, cooling, all those items will, your house will be easier to maintain. And then kind of that is about it in a nutshell for, Title 24. I mean, that's a brief overview, just to kind of get you introduced to it. there's, I've been doing this for 27 years and have seen it change and change and change. So, there are, as I tell everybody, there are no stupid questions except for the ones that aren't asked. So anybody that has questions, even if, always ask your questions of your energy people. We're here to help you. It is a team effort. It's not, and there's no I in team. So it's, we're here to get the best product we can for the homeowner at the best price possible. And, that's kind of where I'm going to leave it. The only other thing that I would have to say is, hold on, sorry. Is the biggest thing is that with the increasing difficulty in the codes, this last code cycle, we saw an increase for the construction in LA alone jump from 45 to 55% increase in difficulty. So houses that worked under the 2016 code, when you move them over to the 2019 code, you literally have to change windows. You have to change insulation. You have to remove skylights. There's a lot of items that really hold us back under this current code. And the way things are going, by 2022 will be the next code cycle. And we'll probably see another 10 to 15% increase in difficulty. And with that,
We have a few questions, Chad, if you are in the chat.
Absolutely. Let me hop out of this. I think. Hold on. Stop share. There we go. Okay. Let's go to the chat. Fingers crossed. Okay. Oh, awesome. Thank you for doing the cool roofs. Can we copy of the slide deck with the recording link? Okay. Does this also apply to solo tubes? Yes, it does. The good part about solo tubes is that the size that we are assessed is usually 1 square foot. So it's literally just the diameter, and that 1 foot diameter skylight can put out as much light as a 5x5 skylight. So you have, much better options. We try and encourage solo tubes. I know they don't look the greatest on the roofs, but the amount of light that they'll provide to a laundry room, to a bathroom, and the fact that they now make light fixtures that go inside the solo tube, it can serve a double purpose of light during the night and solo tube during the day. Audrey, is the modeling considering the optimal overhang differently depending on the configuration of glass below, or is there just one optimal overhang for each project based on location? Yes, the modeling, well, we model however the project is designed. So if you design it with a 2-foot overhang, we will model it with that and see how it benefits us. And the good part is, the software, it takes about 2 to 3 minutes to make a run on the house, and we'll know if it helps or hurts us. If it hurts us, we'll go, oh, well, let's shrink it by 6 inches. Let's expand it by 6 inches. Let's remove it and see what happens. Especially with the way passive heating is now being fed into the energy calculations. We've had projects where we're like, okay, we need to bring them back to like 6 inches, a gutter overhang and a little bit of a lip. And that seems to be optimal, but it's not a guarantee. In the 2008 code and the 2013 code, we used to be able to look at a house and I could tell you without even running it if it would comply, because there was optimal overhangs, as you were referring to, and the buildings the software only ran 2 runs, one at midnight on New Year's Eve, the coldest day of the year, and one at July 21st at noon on the hottest day of the year. So it was just 2 runs and it was fairly, quick and easy getting out. The new software runs the house every 2 hours of every day for an entire year. So it runs 7,700 runs in a 5-minute period. So, which is where the passive heating now has a much bigger effect, because you have longer heating cycles during the summer, and the winters are much shorter. So, that's where the passive heating is definitely being led into. Yeah, I think I answered that one. One question that I have about IAQ and supply vents recently is regarding filtration, especially when there bad air quality from wildfires. Do the supply vents come with good filters? Depends on your mechanical installer if they do the good filters or not. The system that I have on my house that for the outside damper has a 2-inch thick MERV 13 pleated filter, like you would for like a regular furnace, tucked in to the feed line that feeds the return air. So, I mean, there is the possibility of putting filters on it. I don't know if everybody does them or not. Unfortunately, that would be, you would have to speak with your HVAC guy, but, given, the fires, the unhealthy air that, we're all experiencing, I don't see why they wouldn't have it. Let's see. How do credit systems work for solar-ready solar panels and EV charging? Good question. I didn't get to that part, but we can definitely handle that here. With the 2019 code, solar panels became mandatory for all new residential projects. On the equivalent of 1.5 watts per square foot for your project. Now, if you're doing an addition or an alteration, or you're converting a garage into an ADU, solar panels are not required. Excuse me. But otherwise, if it's a new construction from the ground up ADU or a brand new house, solar panels are required. You no longer get credit for solar panels because they are mandatory. There's no getting out of them. Well, let me rephrase that. There are certain areas of California where you do not have to use solar panels. And that's Paradise, California, where the fire was, and then the fires in Malibu. Those two areas were declared emergency areas with AB 178, and thus are exempt from solar if you want them to be. You can still put solar on your house. As I encourage everyone to be doing solar these days, just in the fact that rolling blackouts are going to become a thing for California. I'll get to that in a second. So solar ready is no longer an option because solar panels are mandatory. And with the solar panels, when you're doing your plans, you need to lay out the area of your actual solar panels. Now, it used to be, you could say, I have a 250 square foot area and my solar panels are going to go here, and the tubing, the ducting is basically going to go down to the electrical panel, and you show all of that. Now they want to see the panels, where they're located, panel specs. They want to know about the inverter that's going on, even though most times the solar install is a deferred permit.
Oh. Gone? Hey, Chad? Oh. I feel like it was just getting to the good stuff. Shoot. Okay. All right, well, how many questions do we have left? Let's see. Solar, a design credit for being net zero. Oh, he has a good, we asked him about Tesla Powerwalls recently. He has a good story about the latest with Tesla Powerwalls. So, and then finding a HERS rater. Let's see. Let's give him one more minute here. I'll be right back, he says.
So if you're doing an ADU, sometimes the footprint is so small, your roof is so small. I'm like, and the orientation of the of where you can actually place the ADU on the lot, it's like, I'm like, how are you gonna require
It doesn't
solar?
fit. Yeah. Oh, there he is. He's
Sorry
back.
about that.
That's okay.
I had my computer, I had the camera plugged into my keyboard, and because I wasn't typing on it, it went into sleep mode. So, so let's see. Let me finish the solar one, and then I'll come and answer your ADU question in just a second, Michelle. Okay, so now they want all this information, which is in a deferred permit anyway from the solar installer. So, just kind of be prepared to draw the solar panels on there. On average, most solar panels start at 3 foot by 5 foot, and they're 250 watts. A panel is the smallest panels you can put on a house. They go up to 4 by 6, and they're 450 watts a panel. So you have, it's a little bit bigger footprint, but you get almost double the amount of solar, which could reduce the amount of panels that you have to have. So, and then EV charging, there is no credit for EV charging, but there is actually credit for doing Tesla battery walls and those type of backup systems, and that it's called a self-utilization credit within the report. If you ever see a Title 24 report and you're looking in, there'll be the line that says, self-utilization, and that's actually you're using a battery system to back up your energy, which has so many awesome potentials to making life better for everyone. The ability that if there's a blackout, you don't lose any power. The certain systems that you have plugged into that battery will continue to operate. And the other nice part is your solar panels will still be producing electricity. As it is without a battery system on your house, if the power goes down, your panels stop producing. And it's a built-in safety mechanism for the lineman that's trying to reconnect the 40,000 watt or 40,000 volt line, going, okay, am I going to get zapped when I put these two together? He knows that there's nothing coming down the line until the substation turns everything back on. But if you have the battery backup system, you just keep going. And the cool part is Southern California Edison, I think it's either, well, I know it's them, but I think it might be PG&E too, are offering free batteries to those people that have medical equipment that has to be operating free of charge. So if you have any, customers or clients or friends that are, have to have a breathing machine or have to have, any type of medical device, the power companies are giving battery systems hooked up to your house so that in the event another rolling blackout happens, it won't be an issue. So, let's see, your ADU question, Michelle. What was that again?
Now, I was just saying ADUs can be pretty small sometimes, and depending upon the lot, that you're putting the ADU on, there's not always a lot of options for orientation of the ADU. So there are times when the solar panels, they're not in an optimal place.
No, that makes absolutely. Yeah. The nice part, well, it's not, the code has it written into it that there are certain exceptions for solar panels. One of them is if you have less than 80 square feet of area that you can actually set your solar panels, you're exempt from them. If you're in an area where you're surrounded by trees and you're like, the sun never is going to hit the roof, even on the best day, there are exemptions. And the other nice part is you can actually put the solar as long as it's within 250 feet of the building it's serving. So for example, you could put solar on the main house and have it tie into the ADU, but not have to put it on the ADU.
Oh, that's good.
Yeah, so, you know, they do have the ability to, you know, they do give you options. The other nice thing that is kind of cool, is if you're doing like a tract of houses, you can actually locate the solar like at the end of the cul-de-sac for the entire like street that you're on. So you could have a park system and have, you know, the roofs over there anyway, covered with solar panels that feeds your houses on that street. So they, you know, they're trying to get people to love solar so that it becomes second nature. Because as you've heard and as you know, the state wants to be off all fossil fuels by the year 2030. So, and the problem is wind and solar aren't always around. Solar, you know, solar is only good from 11 to 3 in the afternoon. And, you know, wind is, you know, it's temperamental. Some days it's really windy, other days it's not. So, you know, they want more and more people to have solar everywhere. And then the next step for California will actually be battery farms. So, you know, we'll see where that leads us. But yeah, the ADUs are, they are interesting to say the least, because you, like you said, you have a small square footage, and you usually have, you know, say you have a 400 square foot garage, or I'm sorry, ADU, you know, you'd taken a garage and you converted it, and you have 2 sliding doors, 6.0, 6.8. So you have 80 square feet of glass, and you're just at the maximum 20% window to floor area that the state wants you to have. So then you put a window in the bathroom, or you put a skylight on it, and now you're over the 20%, and they're very difficult to get to comply. But, you know, I applaud the state for doing something with the ADUs. You know, it's, you know, they're popping up everywhere, and they are making a difference housing wise. It doesn't seem like it, you know, if you look at, you know, any street in LA, but, you know, it is, the ADUs are making a difference. I just wish they had done a little bit more to make it more accessible. So, yeah. Does that help? Okay. Let's see, Lindsay, is there design credit for being net zero? Not there. Net zero is an interesting one in that we were supposed to be net zero at this code cycle. The problem arrived when they started looking at the cost of making all new construction net zero. We were exceeding the requirements of the WARREN-ALQUIST Act that I opened with, that you could not place undue burden on the homeowners in order to meet the energy requirement specified per the recent code. So they pushed it as far as they could, making solar panels mandatory, but they didn't do net zero. But our favorite city, Santa Monica, actually requires net zero energy for all new construction. They do offer some benefits for houses that are all electric versus mixed fuel, but only, actually, let me see, Santa Monica, Palo Alto, and one other of the San Francisco suburbs are net zero. The rest of the state, probably 2022 or 2025, net zero will be a mandatory thing. And then we'll be in a whole interesting, another one. So, I mean, there's no real design credit. You know, they've kind of gotten away from the leads, you know, where you had to be 15% better than standard or 30% better than standard. The same thing with net zero. We're not hearing any talk of it. There's no rebates to be had by the state, just because we are in this intermediary step. But come, you know, 2022, we'll probably see credit for being net zero. And then by 2025, it'll be mandatory. You have to do net zero. You know, the Energy Commission works and they try something for 2 code cycles, you know, so for like 2000, like for example, solar panels, in the 2013 and the 2016 code, solar panels were a great way to get your building to comply if it had too much glass, too much skylight, you know, just the windows and doors that the homeowners had chosen wasn't very energy efficient, we'll just say, and you could put solar on your house. So we got 2 years of that, and there were a lot of projects that I got to work by going, oh, we'll just put solar on. And then they went, oh, 2019, solar panels are now mandatory. So you no longer have credit for that. But then they gave us credit for the batteries. So in 2 code cycles, batteries will probably become mandatory, and then net zero. And, you know, it's kind of because they want to encourage people to do these things. You know, they encourage people to do solar because you got credit. Okay, well, now that you're used to doing it, now it's mandatory. And that's kind of the way they cycle, which is, you know, good and bad. It's bad because you're like, oh man, if I had submitted this project, you know, December 31st, I would be fine. I submitted it January 1st, and now I'm stuck with a whole new set of rules. That is actually one other thing. Pay attention to energy code dates when you're submitting plans to building and safety. Have had a lot of projects that were submitted and we thought they were all done. And we're like, oh yeah, we're good. And then all of a sudden they're like, oh yeah, no, the plan checker didn't accept it. So now we have to make it work under the new code. And you're having to rework an entire building that you're like, it took everything I had to get it to work before. So just a small, like, you know, like I said, the next code cycle won't be till January 1st, 2023. So we do have time. But, you know, it's, so whatever year, like, so for 2019, the code started January 1st, 2020. So you have 1 year to get used to what's coming, and then you have to meet it. So just on a side note, let's see, have you had any of your projects use Tesla Powerwall? It's fairly new. Actually, most of my new construction projects, I've been specifying Tesla's Powerwall. We have limited ability in what we can put in the system. We only can tell you, you know, the overall battery capacity, kilowatt per hour. The charging and discharge rate is the only items that we can put into it. And that's how we get the self-utilization credit to show up in the report. You know, there are other companies, you know, LG Chemwall, I think Mitsubishi has something coming out. You know, there's a lot of companies that are producing batteries because it's going to be the future. So let's see, it's not always clear how to source a HERS rater. When can we find HERS raters in our local area? HERS raters, they are actually, if you go to either one of the HERS rater websites, calcerts.com and cheers.org, and you search on those, they have a listing for HERS raters that are registered. You know, and once you find a good HERS rater, you will, you know, they're worth their weight in gold for what they can do for you and how they can help you. And, you know, it's one of those that it's never too early to get them onto a project once you're in the building department. You know, they have ideas because you eventually you'll run into problems like with QII, you know, they'll go, oh, you know, let's fix this area right here before you've drywalled and before you've stuccoed and before you've done all these other items. It makes a huge difference. You know, and actually, and if you just type HERS rater into Google, you'd be amazed at what pops up. You know, everybody, you know, has a company. There are more and more HERS raters being certified and, you know, ready to go. Yeah. Let's see. Let's see. Do they let put solar anywhere else on site but the ADU? Yes. You can put it. Yep. Went through that one. Are solar panels still required if you use a smart thermostat? Yes. even with a smart thermostat, you still have to do solar panels. There is no getting out of solar panels anymore. You know, there are, if you do life cycle costing analysis, which doesn't pertain to Title 24, but it uses the same software, you can use the demand responsive controls of your smart thermostat in order to generate some credit. But within the framework of Title 24 itself, it does not allow the, because trust me, I I have a lot of friends, a lot of people that will be like, oh, we're just going to do smart thermostats. And, you know, they should still be encouraging it, but you don't hear about it much. Like I said, you know, the previous energy code cycles had much more rebate intensive like programs, you know, do solar, do LEED, where you were 15% better than standard, 30% better than standard. You know, now you don't really hear about them anymore, which is kind of sad. And plus, you know, the credit for doing solar, since it's mandatory, went from 30% rebate from the federal government down to 26. And every year from now until 2030, it's going to go down by 1% or 2%. So, you know, if you do have projects that you're looking at, you know, it's a good time to get in and get it. So let's see. Okay, because projects are more complicated and afford to achieve compliance. When in the process do you like to become involved in a project? How do you structure your fees? Realistically, I mean, for most conventional houses, you know, when you're ready to submit to plan check, you know, that's a really good time to, you know, approach, you know, an energy consultant in order to get started. Now, if you have a very modern style house with a lot of glass and a lot of skylights, I would suggest you get with them when you're still in the design phase, when nothing's set in concrete, to where an energy consultant go, okay, if we shrink the skylight, you know, let's pull it in by 6 inches all the way around this square. And that will be enough to get us into compliance. And then that way, the homeowner's not locked on to an idea that, you know, they have to have this. Because one of the biggest problems that we run into as energy consultants is we go, okay, we can't make it work with this much stuff. We've thrown every trick we have in the book. We've done this batteries. We've done every HERS rating we can imagine, and we can't make it work. And sometimes the response we get is, well, that's what we told the homeowner he could have, and that's what we're going to give him. And, you know, so it's, you know, if we can kind of short circuit that whole thing to where we get in before the homeowners are absolutely attached to an idea, you know, that would be a really good time to at least start the conversation. Have somebody look at the calc and go, or the plans and go, oh yeah, you know, this might be a problem. This will be fine. You know, then get their input. Because, you know, like I said at the beginning, it's a team. You know, you get all your team together. You have your structural engineer, you have your, you know, your plumbing engineer, your mechanical engineer, and your energy consultant. You know, California has made Title 24 as important, if not more important, than your structural engineer, which was not the case for the last, you know, for up until about 7 years ago. You know, people did Title 24 and they went, oh, all right, and threw it aside. And that was the last they ever saw it, you know, and now we have projects that are being held up from getting C of O because the windows and doors that went in were changed without the builder's knowledge. The homeowner went ahead and said, hey, I don't like that color. I want this color, and changed it, but didn't tell anybody they were making the changes. And, you know, now we're scrambling going, you know, we've run out of ideas, because at that point, the insulation's in, the windows in, the mechanical's in, the HERS testings are all done. We're like, I don't know what else we're going to do. So, you know, it presents a lot of problems. So if we can short circuit that, and, you know, and we always, you know, I always tell them, like, tell them I said it, you know, so you don't have to, nobody, like the architect, the designer doesn't have to be the bad guy. Energy consultant's fault, you know, blame me. It's cool. Like, you know, But, you know, with the weight that they're putting on it, you know, the homeowners need to be aware that, you know, energy compliance is as important as any life safety report that you're going to get. You know, you're not going to take a structural engineer's report and go, okay, he said a W14 beam. Yeah, I'm going to take two 2x14s and bolt them together, and I'm going to put it up there, and that'll be good. And, you know, like they would never do that. But with energy, you know, they change out water heaters, they change out windows and doors, they add, the biggest thing is they add windows and doors. That's always the fun one when you get a building inspector going, yeah, I'm looking at your plans and the plans show 2 windows and I have 8 on this one wall. And yeah, you need to update your Title 24 report. And I'm going, what 8 windows? Like, I'm looking at the same plan. He goes, yeah, they put in 6 more. So, you know, it's, you know, it's like, okay. So, you know, that's just, you know, last bit of, you know, information I can give you.
Thank you, Chad.
I'm sorry for babbling.
No, you did an awesome job. Thank you. I mean, this is like, it's hard for everyone late. I think this is even an hour later for you. But I think we have been soaking up a lot, and we really appreciate your time.
Yeah, no.
If you guys have, would you mind, Chad, putting your contact information or your email in the chat?
Yeah, absolutely.
And that way people could maybe reach out to you if they have any additional questions, or if they want to make sure that, you know, you're on their list of consultants to check in with.
Yeah, absolutely.
Thank you.
Yeah, I will put all that information on there, and everyone feel free to, you know, like I said, there are no stupid questions except the ones that don't get asked.
Thank you. Yeah.
You know, so even if it's something like, hey, you know, this window or that window, or, you know, we're looking at this, you know, all we do is Title 24. We don't do architecture. We don't do mechanical. We don't do plumbing. It's strictly because of how important Title 24 has become.
Oh, all right. Well, thank you, everybody. And thank you so much, Chad. I know everybody's muted.
Thank you so much.
But thank you. We really appreciate your time. So the next things we'll just say quickly, we're going to put Chad's company, Newton Energy, and his contact information also in the follow-up email that we're going to send after this. Chad, I don't know if you mind, is it possible you could share your PowerPoint, or is that okay, or should we just watch the video? No,
I mean, I have no problem sharing you. I mean,
okay, cool.
Yeah, I think you've already seen half of it anyway.
Yeah,
so.
you guys I already did this presentation earlier.
Yeah.
I'm such a nerd, but yes, we would love to have that, and we'll put that in the email to everyone as well. And also check out, Alejandra posted our YouTube page. It's tiny still. We have some good content, and this will really make it excellent. So we'll put that on there too.
Cool. There goes my anonymity.
Yeah, there it goes, Chad. Well, I mean, we want more followers on our YouTube page, so I feel like you're going to really help us get up there. So
no, for sure. Like I said, I joked earlier that I've been doing this for 27 years, and most people had no idea who I was, what I looked like, and
welcome to the digital era, Chad. Everybody's going to see all of our faces now.
Oh yeah.
All right. Well, thank you everybody for your time, and thank you, Chad, very much. And
you're welcome. Thanks for having me.
Have a great night.